Hi everybody, and welcome again to Campbell's Math Corner. Alright, so this is basically a continuation from the last video where we looked at factorizing. So in the last video we looked at factorizing by using the highest common factor, factorize by grouping in pairs, and factorize using the difference of two squares. So just in case you did not see that video, there's a link in the description to that, so you can always check that out. Alright, so now we're going to be looking at factorizing quadratic trinomials. Alright, so a quadratic trinomial is an expression in the form ax squared plus bx plus c, where a is going to be the coefficient of x squared, b is the coefficient of x, and c is the constant. So to factorize quadratic trinomials, there are various methods that we can use, but the one I'm going to be using today is referred to as the pairing method, where we want to find two numbers whose sum is going to be the coefficient of x. So those two numbers should add to give you whatever b is, and the product of those two numbers should be the product of the coefficient of x squared and the constant. So in other words, we want to find two numbers such that when we add them it will give us b, and when we multiply them it will give us a times c. After we find those two numbers, we're going to use them to split the middle term in the expression, and then we're going to be factorized by grouping. And again, we already looked at how to factorize by grouping in pairs. Alright, so let's see how it works. Alright, so here we have an example: x squared minus 3x minus 4. Of course, the coefficient of x squared in this example is, hope we know that it's going to be 1. Since there is no number there, we know that the leading coefficient there is 1. The leading coefficient of the x variable there is -3, which is b, and the constant term in this case, c, is going to be -4. So we want to find two numbers that will give us the product, which is a times c, and that's -4, and a sum of -3. So of course we know that 2 times 2 would give us 4. However, those two numbers cannot give us a -3 that we want. So we have to consider looking at two other factors that can multiply to give us 4. And of course 4 times 1 is another option. Now, yes, we realize that the product is actually a -4, so it means that we'll have to make one of these numbers negative. Seeing that we want a -3x, it means that we'll have to make the 4 negative and the 1 positive. So of course -4 times 1 will give us -4, and if we add -4 plus +1, then that will give us -3. So it means that our two factors will be -4 and 1. Now, using these two factors, we are going to split the middle term, this -3x we have here. We're going to replace it with these two factors, and that will give us x squared minus 4x, this -4, and this one plus x, and then we write back our -4. And again, some persons are comfortable using writing 1x. If that's the case, then you can go ahead and do that, but in algebra we don't usually write 1. So now you realize that we have 4 terms, and based on what we have already looked at, where factorizing by grouping in pairs can be used to factorize this. Since there is no highest common factor for all four terms, then we can group them in pair. Grouping in pair means that for the first pair, we realize that x is a common factor. So we'll factor out the x, and that will leave us with x minus 4. And the highest common factor for x and negative 4, that's going to be 1. And again, notice we have in brackets, we have common factors of x minus 4. So it means that our answer then is going to be x minus 4. And what's left? X plus 1. So you see, it's pretty simple. As long as we can identify the factors, then factorizing quadratic trinomials should be fairly simple. Alright, let's look at another example. Here we have 3x squared plus 5x plus 2. Notice in this case, the coefficient of x squared, which is a, is no longer 1, but this time it is actually 3. Coefficient of x, that's 5, and the constant c is equal to 2. Therefore means our product in this case is going to be 3 times 2, which is 6. The sum, which is the coefficient of the middle term, or the coefficient of x, is going to be 5. So we need to find factors of 6. So what are the factors of 6? Well, we know 1 is a factor, 2 is also a factor, 3 is also a factor, and 6. But of those factors, which 2 of those factors can we multiply to give us 6? Of course, we know 1 times 6 will give us 6. But if we add 1 plus 6, will that give us 5? I don't think so. Therefore, that's not an option. Consider looking at 2 times 3. Those are 2 other factors that can multiply to give us 6, because 2 times 3 is 6. And of course, if we add 2 plus 3, then we realize that will give us 5. It therefore means that our factors are going to be 2 and 3. Again, all we're going to do is use the factors to replace the middle term, which is this 5x. We're going to replace it with 2x, 3x plus 3x plus 2. And again, we have 4 terms that we can now factorize by grouping in pairs. Grouping in pairs will give us, well, x is common for the first pair. So we factor out x, that will leave us with 3x plus 2. 1 is common for the second pair, so we factor out the 1, leaving us with 3x plus 2 in the other bracket. And again, notice we have common factors in the bracket, so it means that our solution then is 3x plus 2 in one bracket, and what's left, which is the x plus 1 in another bracket. So again, you can see that factorizing quadratic trinomials is fairly simple. And of course, you can pause the video and try these. Alright, if you have tried these, then let's see if you actually got the correct answers when we factorize. So in this case, well, the product is going to be negative 21. That's 1 times negative 21, that's negative 21, and the sum is 4. So we need 2 numbers that would multiply to give us negative 21, and when we add them, it will give us positive 4. Of course, we know those 2 factors should be 3 and 7. Well, the 3 will have to be a negative 3, because we want a positive 4 here when we had them. So, splitting the middle term using the 2 factors, so x squared plus 7x minus 3x minus 21, and that's going to give us x plus 7, x minus 3. Hope you got that one right. For the next one, hope you realize that the product in this case is going to be a positive 12 and the sum is negative 8. So since we want a negative number to be the sum and a positive number to be the product, it means that both our factors will have to be negative numbers, such that when we multiply both numbers we get a positive 12, and of course negative 6 times negative 2, that will give us a positive 12, and if we have two negative numbers then that will give us a negative answer, which is negative 8. So again, factorize by grouping, and our solution x minus 6, x minus 2. On to the next one. Product 3 times 15, that's positive 45, and the sum in this case is a negative 14. So again, two negative numbers, when we add them, which is negative 5 and negative 9, that will give us negative 14, and when we multiply negative 5 times negative 9, that will give us a positive 45. And those are our factors, and again factorize by grouping. Common factor for the first pair is x, leaving us with 3x minus 5, and again minus 3 is a common factor for 9x and 15, so that will leave us with 3x minus 5 in the other bracket, leaving us with a common factor of 3x minus 5, and that's a product x minus 3. So there you have it. That's pretty much how we factorize quadratic trinomials using the pairing method. Alright, so as usual guys, thanks for watching, and continue to watch, like, share, and if you haven't subscribed as yet, please do so, and until next time, see you.